Hey guys, I wanted to just make a quick video of another calculus tip of the day. This time is a request directly from one of you guys, and it was, what's the difference between the intermediate value theorem and the mean value theorem? I know, that's a tricky guy, and so I just thought we should take care of that. So let me switch screens, and we'll do a little example and try to sort this guy out. So here we go. Okay, so today we're going to do, again, the intermediate value theorem versus the mean value theorem. So fun. And I have an example to go with each. One of them you have access to and one of them you don't. So let's just talk about, in general, the difference between these two before we go ahead and do something specific. Okay, so the intermediate value theorem is basically a theorem about y values. Okay, so it's a theorem about y values for a function. Okay, and the mean value theorem, okay, is a theorem, okay, about derivatives. And so that can kind of help us figure out like when we should like which one we should use. So that might be like helpful for you. And so just, yeah, maybe that will assist us. So we're going to do an example of each one of these in this short video and go from there. So again, the intermediate value theorem is about y values. The mean value theorem is about derivatives. In general, the intermediate value theorem says something like, I'm just going to use like a number line super quick. If you know that this value right here is like a negative value, and then this value right here is a positive value, you know by the intermediate value theorem that all the other y values between these two y values, the function will take on as long as the function is continuous. And it will take on all the values. A very special case of this is like that the function would have to equal 0 if you know that there's at one edge, at one endpoint, there's a negative, and at another endpoint, there's a positive. The mean value theorem says it's this. It says that somewhere that the derivative is going to be equal to the same thing as the slope of the secant. Okay, so this is what the mean value theorem looks like, that the slope of the secant, so this would be the slope, right? So if you were kind of like imagining this sort of same picture that we have going on over there. If you had this as a one endpoint and this is another endpoint, that this slope right here, okay, that the function would have to take on that slope somewhere, that exact same slope somewhere in, so it has to do with derivatives. And maybe for us, it could be like right here or maybe right here and right here. So this one actually has 3 spots, but we know it at least has 1 spot, okay? And the same thing about this one. This could also cross this this axis multiple times, like the function could have looked like this or something, but you know that there's at least one time where it will hit the y value if that y value is in between these two y values. So let's do an example of each of these just super quick. Just so you guys can see how this works. So the first example is an example for the intermediate value theorem. And I won't do the whole question, but we'll just do parts of it just to highlight it for you. This is actually taken from the 2016 exam, and it's 1 and part D. Okay, so 1 part D for the intermediate value theorem. The question says something about asking when there's like water coming into something and water leaving, and so what they wanted you to come up with is there a time when the water in would be equal to the water out? Like, when is there a time when these two rates are going to be the same thing? And so what I took this and interpreted as is I wanted to know, I made this say, okay, well, then that would mean that W of t minus R of t would have to be equal to 0. So I just want to know, is there a time when this can happen? And I couldn't really I could graph one of these. I think I could graph the, where's my 2016 on this guy? I could graph the W function because they gave it to me, but this was a table of values. And you're like, oh, shoot, I have no idea. But they did give me an interval from 0 to 8. And so I said, oh, okay, I think I know what to do. I'm going to examine what is the value of this guy right here. So what is this guy's value, right? This guy's value at time 0, and then what's that guy's value at time t? So of course there were some calculations that happened, but at t equals 0, okay, W of 0 minus R of 0 was actually a positive number, okay? Similarly, at t equals 8, okay, W of 8 minus R of 8 was equal to a negative number. So this, in fact, was a positive number, and then this over here, our positive value, and then this over here was a negative value. Okay, and because one of these was a negative value and one of these was a positive value, and this is a continuous function, I know for sure that it has to be equal to 0 in between because of the mean value theorem, and that's basically what I wrote down. So for an explanation, so what was interesting about this question, guys, is that it asked you, is there a value, okay? And it said to explain why. It didn't actually ask you for the value. It just said, is there a value? So once I figured out these two things, that at the first edge, the end point, it was a positive value and the other one was a negative value, then I'm like, oh, well, then of course it has to cross 0 in between by the intermediate value theorem. So that's what I kind of wrote down. I said by the intermediate value theorem, and you can go ahead and abbreviate that because it is an acceptable abbreviation. I said something like there guarantees an X value between t equals 0 and t equals 8, where W of t minus R of t is equal to 0, and then I put or W of t equals R of t, and then I said because, and then I basically just wrote my findings up here. I said because W of 0 minus R of 0 is greater than 0, and W of 8 minus R of 8 is less than 0. Something like that, okay? And that's how we do it. Well, that's fun. So much fun. I love teaching outside, you guys. It's kind of amazing. Okay, and then that would be an example of the intermediate value theorem. An example of doing the mean value theorem, I'm going to be honest with you, folks. This one was a doozy to find. So you don't have this in front of you. I had to just research, but there was this question. I have this like resource that I can look at. And so this was a question from 2002, Form A of the test, of the AB test. Whew. Okay. This was question 6, and it was part C. Okay. And so this actually took me a while to find a mean value theorem one, but we found one, so I'm gonna share it with you. Basically, there was like this table of values. And in this table of values, it gave us values for x, and then f of x, and then f prime of x. Okay, that's what it says. And then this is what part C of the question says. It says, I'm just going to rewrite the question. Find a positive real number R having the property that there must exist a value C with 0 being less than C being less than 0.5, and where f double prime of C is equal to R, and then it said to give a reason. Okay, so this was the question that they asked us. And so there was a couple of things that alerted me to the fact that this was going to be, in fact, a mean value theorem question, okay? So one of the things that I noticed is that this guy stops at f prime, okay? So this is like the last level of information that they have given us, but then all of a sudden they asked something about f double prime, and then they also gave me an interval. And so I knew that this had to be something to do with the mean value theorem. So I'm going to erase this and talk about how the mean value theorem would work for this guy. And then there are some values that were on the table, just like of interest to us. So there were different values in the table, but one of them, this was a 0 and this was a 0.5. This was -7, this was 0, this was -6, and this was 3. So those values were on the table, so I'm going to use those. So with that being the question right there, doing the mean value theorem, okay, because it said something about that f double prime of c, I knew it was a mean value theorem. So what they're doing on this one is they're asking about a derivative. Okay, so, and I know that they're asking about the second derivative, but what they've given me in the table is up to the first derivative. So this is asking about the derivative of basically f prime, which is f double prime. And they're asking what that value is, right? That's going to make this work. And so basically for us, if I were to set this up according to the mean value theorem, f double prime at c, which I don't know where that is, right? I'm not sure, but it says it's between, the interval was from 0 to 0.5. So it would be f prime of 0.5 minus f prime of 0 over 0.5 minus 0. So I know that it's weird that we're doing it with the second derivative. Normally, this is the first derivative and this is the function value, but we're just kind of like bringing it down a level. So then this is the first derivative that we're using for our regular secant slope. And then this is going to be our second derivative for our like slope that we want to match the secant. And so basically what they did in this question is they went ahead and just put in the numbers. This was a 3, take away a 0, and then over a 0.5, which turns into a 6. And so it said, where was r equal to f prime of c? And so this answer to the question was where r equals 6. Okay, so ladies and gentlemen, that's about it for our quick little video on the difference between the mean value theorem and the intermediate value theorem. And so hopefully that was a nice explanation. So in general, just from the beginning, the intermediate value theorem is talking about particular y values and can you find a y value? And there's usually an interval. The mean value theorem is going to do like a mix, right? They're going to want some sort of derivative of something like to equal the secant slope. So those are like the two differences. So hopefully that's helpful as you're going through your FRQs. And I think that's it. You should be golden. All right, guys, I will see you later. Adios. Bye.